Comes on everyone. Let's start off. The last thing that we did was the spring problem. Let's go ahead with more problems. Let's say we have a block here connected to a spring K. The floor is smooth. Initially a natural length. And initially the block is at rest. Then what you did, the tip of the spring, let's call this point A, you started pulling this thing with speed U. Is pulled with constant speed U. Right? So now what will happen if you start pulling this? Initially the spring will stretch. Because the spring stretch, the block will start moving. But because U is greater than the speed of the block, the spring will keep on stretching. You're getting it? So it will be oscillating and the point is also moving. So both are happening at the same time. So in this, find maximum elongation. What is the maximum elongation in the spring? Second question, what is the maximum speed of the block during its motion? Find work done by the external force when the spring is maximum elongated. So when it is pulled with constant speed U, someone must be pulling it, right? It won't go on its own. So how much work did that external force did and work done by F external when spring is max elongated? Question 4, instead of constant velocity, if A is pulled with constant acceleration, then find maximum elongation. There are 4 questions, everyone. I hope the picture is clear, everyone. We got a block at rest. We had a spring constant K, and someone started pulling this point A with constant speed U. Find the maximum elongation, find the maximum speed of the block when you're pulling it, and find the work done by the external force till the maximum elongation. Fourth part, instead of U, if you pulled with a constant acceleration, then what would have been the maximum elongation? Think. That is okay, Samyak. Go ahead. Anyone not clear with the picture, didn't understand the diagram, please ask me. Rudransh, can you keep your cam on? This is a good one. Anyone not clear with the picture, please ask. Oh, okay, Rudrash. Got it. Right, Utsa. Right, Ishwan. Right, Ovia. Yeah, most of you got the first part. Then, so how do you handle the first part? I'll tell you one thing. See, this is like a clue, okay? Whenever you hear these words, something is going with constant velocity, something is going with constant acceleration. When you hear these words, understand the best thing to do is take the observer, keep it on that point. So, when any object or system, generally, that is how it works, goes with constant velocity or constant acceleration. Again, this is not a concept. When you do a lot of problems, you will realize because it is going with constant acceleration or constant velocity, your life actually becomes easy. Normally, what will happen in the ground frame? A is also moving, block is also moving. It becomes confusing to see everything. But if you can keep one guy at rest, your life becomes easy. So for the first part, I will take my observer and keep it M. So this is block M. This is point A. Now, if you go and stand at point A, this guy will think, okay, I'm at rest. But now he will think the block is going backward with you. Isn't it? This is with respect to A. But standing at A, won't it create any problems? Luckily, here it won't create any problems because since velocity at A is constant, there is no pseudo force. It is an inertial frame. Uh, any frame which has zero acceleration is an inertial frame. So if you're standing in an inertial frame, then there's no problem. Your life is easy. This is what this guy will think. Next thing, how to solve problems. Step one, choose your system. Block is my system. Step two, define your initial state and final state. This is my state one. My final state, you said maximum elongation. So this becomes like, you know what? This is the fixed wall and the block is simply oscillating front and back. Is that making sense? When you go and stand on A, it will start feeling as if, the point A is fixed like a wall and the block is simply oscillating front and back like a oscillation. So this will be block M. This is point A. Remember, A is still at rest. This block will come to rest. Why it will come to rest? Because maximum elongation. So from here, it must have stretched X max. Because if the block does not come to rest, the block will continue to go further. So it will not be maximum elongation. This is my state two. So my state one is the initial velocity thing, and state two is when it comes to rest. Then there are no external force on the system. Remember, A is at rest. So even if there is a force, the work done is zero on that point. It won't matter. So energy in state one is equal to energy in state two. So with respect to A, there are no works done. Are you getting it? With respect to A, there is no external force on the system. What is the initial energy of the state one? Spring energy is zero. Kinetic energy is half mu square. State two, kinetic energy is zero. Spring energy is half kx square. Therefore, x max is equal to u into root over m by q. Straightforward. If you go and stand on the Eka frame, suddenly your life becomes easy to solve. Yeah. What is the second question? Find the maximum speed. How will you do that? Right, Samyak. Right, Ovia. And then what is the work done by the external force till the maximum elongation? Let's see. Now, again, whenever I ask you find the maximum speed, remember I'm asking in the ground frame, right, Anvita? So the B part. Now, when you go and stand on A, what will you see? If you're standing on A with respect to A, you think you're going with speed U? So if you just look at the block of motion, this is what will happen. This block is starting from your mean position, which is your natural length. So at this position, at this point, the speed is your maximum speed. This is your maximum speed. That is your initial speed. So this block will go till somewhere here. This is your X max, which we calculated. Then your speed becomes zero momentarily, but the spring is pulling you back. This is extreme position. So the spring will pull you back, Kx. So the block won't remain at rest. Again, it will come back to the mean position. But this time when it comes back, the speed becomes u on the right-hand side. Make sense? And it won't stop there. The block will continue to go further. Then it will stop somewhere here. Then again v becomes 0. This will be another x max. And then again block will keep moving. So this block will just keep doing this forever. Again, with respect to A, this is what A will think. Is this making sense? So you want to find velocity of the block with respect to ground, which is nothing but velocity of the block with respect to A plus velocity of A with respect to ground. So if you look at this velocity of B with respect to A, this will be U I cap. A ka velocity is constant. So if you look at this block ka velocity with respect to A, this thing is not constant. This is varying. This is varying from minus U I cap to plus U I cap, isn't it? It is going U I cap backward to U I cap forward. So if you want maximum speed, what should I take? You should take maximum speed ke liye, I should take it as U. So that means the maximum speed is 2U. Is that making sense? So when the block is coming towards the right side with the same speed U and the A is also going with you, then the speed with respect to ground will be 2U. So in the ground frame, this is the velocity. Remember that if they don't mention anything and they simply ask you velocity, they're always talking about ground frames. Clear this? Still the question is not over. What is the third thing? Work done by the F external. Again, that means you are asking in the ground frame. Remember, you are taking A ka frame because it is convenient to solve the problem. That was your choice. You're getting it. Observe the question where they never mentioned A ka frame. It is always in the ground frame. We are taking A ka frame because it is convenient for us. How do you find the work done? We know work done by when spring is maximum elongated. That is when you want to find the work done. When spring is maximum elongated, look at the scenario. This observer A will think it came to rest. He will think it came to rest. Matlab V relative is 0. Block ka velocity is not actually 0. So this is with respect to A, it will feel the block is at rest. But actually, if you see this in the ground frame, V relative is 0, meaning here. The block and the point A both are going with the same speed. I hope you're getting the meaning of this. A will think the block came to rest, but A himself is going with you. Making sense? Now ask yourself, initially what was the energy? Initially block was at rest. Initially spring energy was 0. Suddenly where did he get all this energy from? So this is what the guy in the ground frame will see at maximum elongation. So work done by external forces will be change in potential energies plus change in kinetic energy. Initially potential energy spring was at rest. Finally potential energy half k x max square. Initially block was at rest. Now the block is going with half mu square. But we know half k x max square is nothing but half mu square, which we derived just now. Mu square. This is the total work done by external force. Simple logic, see. Initially, when you're throwing, what is blocker kinetic energy? 0. What is spring energy? 0. There was no energy anywhere. Now suddenly, when there is a maximum elongation, what is the spring energy? Half kx square. What is block energy? Half mu square. Who gave you all this energy? It must have come from somewhere, isn't it? And the only guy who can give you this energy is an external guy. That is how you can figure it out. Is that argument making sense, everyone? And what about the last thing? What if you have a constant acceleration? Again, same story. Go and stand on the point. I think some of you did get it, right, Anvita, you got it. How do you do that? Try, I'll give you another minute or two for that. Instead of constant speed, if you have constant acceleration, then what is the maximum elongation? Nay, Samyak, that is wrong. Think. Yeah, I can't hear you, right?
So is the motion of A starting from rest?
Starting from rest.
Okay.
You have one answer for the fourth part. Let's see. This is going with acceleration A. With respect to A, if you go and stand, the observer will stand at A, so there will be a pseudo force, which is M into A. Then what will happen? And remember, initially your velocity is 0. This was your natural length. The block will keep moving, M. This is point A. At some point, understand one thing, at some point, your Kx becomes equal to MA. But don't forget, by now, the body must have gained maximum speed. We will talk about this in more detail in one more question. But this thing won't stop at the mean position, isn't it? This is your equilibrium position. Think about it. When you take a pendulum here and when you release it from here, why don't the pendulum stop at the lowest position? Because the pendulum, when it is the lowest position, it has maximum speed. It will continue to go further, isn't it? You're getting the catch. So at this point, you have maximum speed. Block won't stop. It will continue to go further. The block will stop when the velocity is 0, when not maximum. So that is a mistake. So some people write kx is equal to ma. That is not your maximum elongation. This is your x max. So at this point, so pseudo force is still there, but your spring force has become so much. So here your spring force kx max is greater than ma. So the block will actually go back. It will just keep on oscillating front and back. So what is my state 1 and state 2? My state 1 is this. My state 2 is this, the extreme position. So what is the work done by pseudo force? Now remember, the external force, there is a pseudo force. Work done by pseudo force is pseudo force ma into displacement, which is x max. So work done by external plus pseudo forces will be final energy, state 2 minus initial energy. This will be ma x max. Final state, this state, kinetic energy 0, spring energy half k x max square. Initial energy, initial spring energy is 0, initial kinetic energy is 0. So I can write here, initially spring energy is 0, kinetic energy is 0. Finally, spring energy is half k x max square. Finally, kinetic energy is 0. The block comes to rest momentarily, then it goes back. Therefore, we get x max is equal to 2 ma by k. You get double that equilibrium. The block won't stop at the mean position. At that position, you'll have more speed, so you will continue to go further. The same reason why pendulum doesn't stop at the lowest position. Any doubts on this?
Sir, so after the mean position,
Hmm.
the velocity starts to decrease and the
Yeah,
spring.
it'll decelerate.
So the spring has to do the same negative work it did to give it that velocity, right?
ऐसा बोल सकते हो. Basically, the spring is absorbing all the energy, ना?
या सो इनिशियली जितने जितना नेगेटिव वर्क उसने किया टू गिव इट दैट वेलोसिटी उतना वो अब वापस ले.
No. See, spring is never giving the energy. Pseudo force is giving. Spring is always absorbing.
ओ यार
The
राइट
one who
मैं
is giving work is.
मतलब जितना सुडो फोर्स ने दिया बढ़ाने के लिए उतना स्प्रिंग अब लेगी.
Obviously, ना. हाँ, मतलब वही हो गया ना. Or work done by entire pseudo force went into spring only. All clear with this? It's a good question. Matlab, I kept dumped all the questions in this one thing. Even though it looks like one, we did multiple things there. It could be a good, decent question. Let's see one more. Let's do something little more easy, and then we'll go ahead. So we have a pendulum here. This is fixed. Length L, mass M. This is theta. Find theta if magnitude of initial acceleration and acceleration at lowest position are equal. Again, magnitude. Release from rest. So when you release from rest, there'll be some acceleration. When it reaches the lowest position, there'll be some acceleration. And they're saying these two are equal. Then what is theta? I'm asking what is theta? What are you finding? What is V? Where did I give V here? Karna, aram se. Why are you so impatient? Try. Everyone should try. Inverse 1/2. Okay. I don't remember the answer actually. Let's see. We have one answer, not sure whether it is right. 2 times tan inverse 1 by 2. We have 2 different answers. Anyone else? So let's see initially what is the acceleration you have. Initially your velocity is 0. So centripetal acceleration is 0. So initially when you release from rest, V is 0. So A centripetal is 0. So whatever acceleration you have, this is mg, this is theta. If you look at the components here, this is mg cos theta, this is tension, and this is mg sin theta. So this mg sin theta is creating your A tangential. So mg sin theta is mass into A tangential. So A tangential is g sin theta. This is your initial acceleration. When you come to the lowest position, you must have gained some speed. How much is that? This will be the difference in height, L minus L cos theta. This is L cos theta, the adjacent side. So loss in potential energy is equal to gain in kinetic energy. So this is my state 1 and this is my state 2. So mgl 1 minus cos theta must be equal to half mv square. Great. Now when you're at the lowest position, this we have tension, we have mg. At this position here, A tangential is 0, but we have A centripetal, v square by L. So A centripetal is v square by L, and here we know v square ka value 2gl 1 minus cos theta. This is 2g 1 minus cos theta. So basically at the lowest position, we have centripetal acceleration. At the initial position, we have A tangentials. Making sense? Because there's no horizontal force at this thing. And now you are saying these two are equal. So you are saying the initial A tangential is equal to this final A centripetal. Again, magnitudes. The directions will be in different directions. G sin theta is equal to 2g1 minus cos theta. G will cancel. Sin theta can be written as 2 sin theta by 2 cos theta by 2. 1 minus cos theta can be written as 2 sin square theta by 2. 1 sin theta will cancel, 1 2 will cancel. You will end up with the tan theta by 2 is equal to half. So theta will be 2 times the tan inverse half. Clear with that?
So technically, pi is also a valid answer.
Which one?
So for this one,
What?
so like sin
4 by
theta.
3.
No, yeah, that's correct. That's for tan theta. So,
Hmm.
but like also pi is also a valid answer, right? Because sin theta is getting
Pi.
cancelled. Sin theta by
Eh,
2. So technically, we
pi.
will have two roots.
No, I didn't
Theta is
understand.
equals to
Pi
0.
matlab you're saying 180 you're saying.
180. Because
Are string
the
है God. That is a string, na? If you keep 180, so it will just fall down straight.
so I mean the acceleration is still the same, so it satisfies the condition.
Theta
It will be 0
satisfy.
degrees. Then. Initially,
नहीं रे God.
like
Initially you leave from here, तो कैसा गिरेगा? सर्किल में तो जाएगा नहीं वो.
सर तो सर्कल में जाने का जरूरत नहीं ना इन द एंड वो एक्सेलरेशन
So
तो
it
सेम
will just
देना
fall straight. It will fall straight there, and at the lowest position, what will be the acceleration? It will just stop.
या इट्स जी राइट
Why it will be g? The string will suddenly become taut.
अच्छा, इन द लोएस्ट पोजीशन। ओके, आई मीन ठीक है
ना
सर, बट
फिजिकली इट
लाइक,
डजंट मेक सेंस ना.
हाँ राइट, ओके। मतलब उसको जस्ट स्टार्ट होने के पहले अगर हम देखेंगे तो वैलिड है।
ठीक है. Clear with this? All got this? So it's basically a circular motion question here. We are just playing with the race interpreter and a tangential. Any doubts on this? Clear, na, Shreyan? Vanchika? Clear this? Vedika? Ashvi? Siddesh? Anvita? Aditi? Got this? Advait? Advai? Next one. Let's say we have a block here of mass m connected to a block of mass 2m. This thing is placed on a ground. Okay. Initially, the system is at rest. Then what you did from this initial position, you press this block by y. You pushed it down by y. And then you released it. So you pushed the block by y and you released it. When you released it, what happened? The upper block started going up and something happened. You got a situation like this. This lower block actually loses contact with the ground. It flies off. So the question is, find y minimum if the lower block just lifts off. Find y if the lower block just lifts off. Matlab, it's not really flying off, it just loses contact and then again touches back. If lower block just lifts off, you can write y minimum also. But is the story clear, everyone? Initially, we have a m block and 2m block system is at rest. Now what you did, you pushed that upper block by y down, you compressed it, and then you released it. You removed your hand. Now, because you compressed it, this block M will fly up, fly up, fly up. At some point, it is going so fast, it will start pulling the spring up, and the 2M also will go up. And then it loses contact. So, what is that? Mere Arya. You just remembered it for some other question. I know that. Numbers change kya? Try kar. It's a good question. Let's see how you approach this. I'll give 3-4 minutes. But anyone didn't get the scenario. What is happening with the story? That let's be clear with that. Hmm. राइट हो गया? नहीं शौर्य, इट इज रॉन्ग. Right, Siddesh. You have two answers, everyone. Try. Everyone should try. I'll give you another minute or so. Think of what is happening. It's completely fine if you don't get an answer, but like I keep saying, if there are 4 to 5 steps, figure out 1 or 2 steps. How is the block moving? Why it is moving like that? What is it? And everything. Let's see. So listen carefully. First thing, the first question you need to ask yourself: is the spring in natural length? So this was M. And this was 2M. You said initially it is at rest. That means this mg is being balanced by spring force kx. So x is equal to mg by k. Initially, the spring is not in natural length. This is your natural length. Because think about it, if the spring was in natural length, who is balancing mg ka weight? This is your natural length. That means initially, the spring is already compressed by an amount of mg by k. That's the first thing you need to realize. Then what you did, now you pushed it further y. So from this position, you pushed it by further y. So the block came here. Like I keep saying, the important thing, if you draw the pictures properly, you will understand what is happening. Now this distance became x plus y because you pushed it here. And remember, your velocity is 0. You are leaving from here. So my problem starts from here. This is my state 1. You're getting it? So after pushing it, you released it, right? The question starts from that position. नहीं उत्साह, नहीं Ishwan. Okay. Now after releasing, what will happen? This block will start flying up. Now remember here, the spring is compressed. So if you look at the picture at any time, let's say when you're somewhere in the middle, understand one thing, spring is still compressed. So that means what will the spring do? The spring is actually pushing the block down. Weight is also down and will be also here upward. So here the block cannot lift off. If you see in this position, as long as the spring is compressed, getting it? The block will not lift off. So the lower block is being pushed down. So lower block does not lift off when the spring is compressed. If it wants to lift off, someone should pull it up, not push it down. So lower block does not lift off when spring is compressed because spring will keep pushing you down. Weight is also pushing down. Who is pulling you up? when spring is compressed. So this block will continue to go up. It will reach the natural length. At this point, the spring has come to the natural length. Then the block won't stop there. It should still go further. Now, because you want the block to lift off, the block must have gone to extension. So let's say this elongation is some Z, something. So now the spring is elongated. So this elongation Kz, 2 mg. So if Kz becomes greater than or equal to 2 mg, the block lifts off. So that is the thing you need to realize. For the lower block to lift off, the spring must be in an elongated state, not in a compressed state. So here you can clearly see, so Z ka value will be here, 2 mg by K, since you're asking for minimum. Remember, this is elongation, and at this position, your velocity is again 0, because again, you're asking for minimum. So the block will just reach 2 mg by K and then will turn back again. At this position, you will lose contact and becomes 0. This is my state 2. There, this is your picture. So basically, you're conserving energy between this state and this state. But before directly jumping into the problem, you should have an idea what the hell is happening in the whole problem. How did it start? What is happening while it is going up and everything? The explanation part is more important. Ask me if you're confused. Yeah.
So initially in the question, it's mentioned that the block was like in equilibrium with the spring.
No, initially system is at rest.
Okay. I took it.
Bas,
That's
itna
why.
hi hoga na. So you need to figure out it will be compressed. If it is not compressed, block will, there's no one to balance mg. Is the picture clear, everyone? So this is what I keep saying, when I say think about a question, this is what I want you to do. I'm not expecting you to get an answer. You need to do an analysis like this. If you just try to just put the equations and get an answer, you will be stuck. Any doubts on this part of the story? All clear with the explanation what happened. Now let's conserve the energy. So I know my initial state, I know my final state. So I'll just erase this stuff. So this is my initial state. I need to define my reference line. I will choose my natural length as a reference. Actually, I don't need all this anymore now. So I'll choose this as my reference line. State 1, gravitational potential energy. The block is x plus y down, so minus mg x plus y. Remember the 2m block never moves, so we don't care about the 2m. Spring potential energy. Half k, remember half k x square, x is the total elongation or compression from natural length. It is not half k y square. Kinetic energy, 0, you're starting from rest. State 2, gravitational potential energy, mg z, which is 2 mg by k, above the reference line. So I'm taking the natural length as a reference line for potential energy. Spring energy, half k x square, where x is the elongation or compression. Here it is 2 mg by k. Kinetic energy, 0. Are there any external force on the system? Yes, there is an external force, normal reaction on the ground. But is it doing work? No. Therefore, work done by external force is 0. Energy in state 1 is equal to energy in state 2. What is this x actually? This x is mg by k. So if I equate all the stuff, I will get minus mg by k plus y plus half k x plus y whole square, which is mg by k plus y whole square, is equal to mg 2m square g square by k plus half k x square. So that is half k 4m square g square by k square. Expand this. Yeah, this looks big. Minus mgy. This will be half k m square g square by k 2mgy by k plus y square. This would be 4m square g square by k.
Sir,
Yeah.
So can I suggest some calculation?
Nah, don't suggest.
Okay.
Let me do what I want. I'm happy with my calculations.
So I mean, just everything
So
just goes off in one step.
I know कुछ तो होगा बाद में देखते हैं. No, let me solve my way. If you got a better calculation, it is fine. First, let me finish off my way. Then ये क्या था? MGY and this thing. This terms also will cancel off. So you are left with half k y square. No, wait, I messed up something, I guess. Will that get cancelled? Yeah, that should get cancelled. नहीं ये रेडी कैंसिल नहीं होगा. That would be how much? Half k y square when it goes that side. M square g square by k. This will be 4 plus half. That would be 9 by 2. 2 goes off. We get y is equal to 3 mg by k. अभी बताओ.
Sir, instead of actually putting the values of x, y, and z, you could have just put
Hmm.
x, y, and z, and then it becomes a square minus b
मतलब you're
square.
saying put this as 2x ऐसा?
Uh, I mean, that's not 2x. Okay, no, not like that. Like, just put it x, y, and z. Doesn't matter.
Okay. Then simplify हो
And
जाएगा बोल रहे.
then a square minus b square, and then entire thing cuts off, which you cancel. And
There.
directly you get
So
mg by.
you can do that also. But like I said, exam में मुझे तो इतना click नहीं होगा. I would have done this only. So you see what works for you. You're confident you can do it. Nothing wrong. Clear with this? My job got over after writing E1 is equal to E2. Then it is just a matter of solving. Yeah, you have a better way of doing it. But clear with the steps, everyone. The main thing is this picture actually. What is happening? If you don't do this properly, then after that, whatever equations will come, that is fine. That is manageable. Any doubts on the steps? Clear with this? Let's see one more. Any doubts on this? Advai? Clear with this? Chaudhya? Tanishka? Pratyasha? Clear with this? Next one. Next one is a standard question. It's the standard result, but we will do it in more detail. Like I said, it is not about the question. I really want you guys to analyze and understand, okay, what is happening? What happens after this? What happens after that? So we have a block here initially in natural length. You released it from rest. So maybe initially you're holding the block, kept the spring in natural length. Block is released from rest. Find the maximum speed of the block and the maximum elongation in the spring. During its motion. So you took a block with a spring in natural length and you just left it. So this block won't just keep quiet. This will start oscillating up and down. So find the maximum elongation in the spring and what is the maximum speed of the block. Try. Give it a try. Hmm. Right, Arya. The elongation is fine. Space root G by root K. Dimensions मैच नहीं हो रहा है. Right, Siddesh. Right, Ishman. Think. Take me a minute more, then I'll show you the steps. Nee, Vanshika. See, Vanshika, that's what I was telling you. You won't stop at the mean position, isn't it? When kx becomes equal to mg, your block will have more speed, so it will not stop. You'll continue to go forward. Right, Utsa. Right, Shaurya. mg by root kid. Arya dimensions अभी भी match नहीं हो रहे हैं. Samyak, that's right. Let's see. So let's try to analyze the whole situation, right? Solving is actually easy once you understand what is happening. Listen to this thing. So initially a block is here, M. This is in natural length. Okay. This is state one. Now at this instant, since there is no elongation, Kx will be 0, gravity will be mg. So this block will start falling with A is equal to g. Velocity is 0. So this block starts with an initial acceleration g and there is no velocity. Then from this state, the spring will elongate a bit. So the spring will stretch a bit. Now the force will be Kx upward. Your weight will be acting mg downward. But remember, the gravity mg is still greater than Kx. Suddenly they can't become equal. That means this thing is accelerating down and velocity is also down. This block is speeding up. Again, you don't need this actual for the actual problem, but let's see analysis. What will happen? Then this block will continue to go further. At some point, you'll reach a state where your Kx becomes equal to mg. This is your equilibrium position. Equilibrium or mean position. So at this position, acceleration becomes 0, but you have gained maximum speed. Because still now, mg is greater than kx, so it is speeding up. So you have gained maximum speed here. So the block won't stop here. Then this block will continue to go further. This is kx. This is mg. Now the spring force has exceeded mg ka value because you're stretching more than equilibrium. Now the acceleration will be upward, but your velocity is still downward. You're still going down. You suddenly won't stop. Now the particle is slowing down. Then from here, this will still go further and eventually it will stop. V0. At this position, this is x and this is mg. Your acceleration will be up. This is your maximum elongation case. But since it is pulling up, it won't stop here. It will continue to go up. Now remember, spring is still elongated, but it is closing. So kx, mg. So here kx is greater than mg. So this will accelerate up. The spring force is greater than mg. So the block goes up with acceleration. Block ka velocity is also be upward. Again, it is speeding up. Then again, you reach a state kx and mg, where kx becomes equal to mg again. Again, you reach equilibrium. At this point, your acceleration becomes 0, but you have got maximum speed in the opposite direction. This is again equilibrium. So there are 2 times you'll get maximum speed in one oscillation. Then this is kx, this is mg. Now mg has become greater than kx again. Now the block starts slowing down. Your velocity is still up, but your acceleration is down. You'll slow down. Then again, the block will come back to the natural length. And this will just keep on going forever. This cycle will just keep going forever. So if you look at the states here, this is my state 1, this is my state 2, this is my state 3, this is my state 4, state 5, state 6, state 7, state 8, and again back to state 1. So this spring block system will go through these 8 states continuously. Now in this, the question asked is find the maximum speed and maximum elongation. So you're interested in state 1, state 3, and state 5. State 7 also you can take, but okay. Are you clear with this? Now in the exam, you should know which state you're talking about. So I don't, I'm not expecting you'll write all this in the exam. It's a waste of time. But while understanding, you should know, boss, when you leave a spring block, this is what is happening with that spring and the block. Is this picture making sense, everyone? This is a complete cycle. It will just keep going around. So getting an answer is easy, but you should know what are the states going on. So this is what I mean by analyze a question. When you see a question, you should know what is happening end to end. Any doubts on this? So did you observe here at equilibrium, it won't stop. So never write kx is equal to mg. So now how to do the question? Now it is fine. Take your states. So this is block at natural length. So you're considering state 1, you're considering state 3, and you're considering state 5. Basically, this is your mean position or equilibrium position. This kx is equal to mg, you have maximum speed here. X mean is mg by k. This is your v is 0. This is your maximum elongation. Great. So I'll take the natural length also as a reference line. Energy in state 1 is equal to energy in state 5. Initial potential energy, 0. Initial kinetic energy, 0. This thing potential energy minus mg x max. Spring energy half kx max square. So we are choosing this line as a reference for gravitational potential energy. We get x max is equal to 2 mg by k. So that is one thing. You can actually, remember that you always get double the mean position. And for maximum velocity, conserve energy between state 1 and state 3. Initial spring potential energy, 0. Initial kinetic energy, 0. Initial gravitational energy, 0. State 3. Initial potential energy minus mg x mean. Kinetic energy half mv square. Spring energy half k x mean square. Substitute the values. So this would be mg x mean is again mg by k. This is half mv square. This will be half k mg by k whole square. Solve this, you will end up with m into root over g by k. G into root over m by k. There, you get something of that sort. Check it out. Clear the steps. Yeah, you will do this in SSM again. This is what is happening. Is this thing clear, everyone? I hope everyone got this picture. This idea is important. How is the spring behaving? How is the block going? Now, once you know this exam, you will not do a mistake. Equilibrium, most common mistake, kx is equal to mg. You will stop doing that if you understand why it won't stop at equilibrium. Any doubts on the steps? All clear with this? Take a break. Come back by 9:40. We'll continue from here. Any doubts so far? Chalo, come back by 9:40 then. Yeah, let's see one more. Let's say we have a block of mass m connected by a spring. This is 2m. Spring is in natural length. This block is smooth, whereas this block is a rough. Initially, everything is at rest. Now what you did, you started pushing this block with a force F. So the thing is, find the minimum F. If 2m block just moves. Let's get this, everyone. Cams on. Mu mg. नहीं नहीं Samyak. Again, you guys are doing the same mistake. You guys are assuming the block will stop when force is equal to kx. Keep that in mind. Blocks don't stop in equilibrium. In equilibrium, they'll have maximum speed. They will continue to push forward. No, Shaurya, that is wrong. Think. There's another standard model. No, Siddesh. Right, Arya. Right, Samyak. We have answers. Now, let's see. Again, like I keep saying, always define your initial and final states. So this was your equilibrium position. You want the block to just move, right? So 2m is still there only. So you want to block, you want the block to come somewhere here. That means if you see the spring force, whatever is this, kx, must balance this friction, which is 2 mu mg. That means x must be 2 mu mg by k. That means this block must have traveled distance x. Isn't that right? So if the block travels distance x, this will move. So, and again, you just want it to come to rest because you said minimum. The block will just come to rest. So you're done. So work done by external force is equal to E final minus E initial. What is the external force? Capital F. F is constant. It is pushing how much? F into X. What is your final energy? Kinetic energy 0, spring energy half kx square. What is initial energy? Initial energy, kinetic energy 0, spring energy 0. So we get F is equal to kx by 2. But what is X? 2 mu mg by k. Mu mg. The mistake you guys are doing, you thought F must be equal to 2 mu mg. So I'll tell you what happens. If you apply F is equal to 2 mu mg, you know what will happen? Agreed. The block 2 will definitely move. There's no doubt. But that will be the equilibrium position. That means the speed is maximum. So the block won't stop here. The block will still continue to go further. So then the answer won't be minimum, right? Question is find minimum. Means you applied more force than required. Is that making sense? Any doubts on this? Yeah, I think now you're all getting it. So if I actually draw the full picture now, this is how it would look. If you want, I'll draw that. This was the initial situation 2m. This is your natural length. So when this block moves, you will come somewhere here. This will be your mean position. You won't stop here. At this point, I agree. The kx will equal to balance this, but at this point, the speed will be maximum. This block will continue to push forward. You will reach somewhere here. So at the maximum compression, I want the block to move. So this would be your x max. I hope this is clear, man. Block will never stop at mean position. If you are gently placing it, that's a different story. But if you are just pushing it and leaving it, this is not going to stop there. Clear this? Let's see one more. Any doubts on this? Let's say x is equal to t square by 2 plus t power 4 by 4. T is time. X is x coordinate. So particle is moving on the x-axis. Mass is 2 kg. Find the work done in 2 seconds. Let's get this. Hmm, 2156. Let's see. Now, one way to do is you can differentiate, get acceleration, get force, and do all that stuff. That goes quite long. There is a much easier, faster way to do. Work done by all forces is change in kinetic energy. Ke final minus Ke initial. Great. What is velocity? Dx by dt, which is t plus t cube. So t is 0, velocity is 0. At t is equal to 2 seconds, velocity is 2 plus 8, 10. Therefore, work done will be half m, mass is 2 kg, 10 square minus 0, 100 joules. Bus. Clear this? Just get the initial velocity, get the final velocity, and then finish it off. Work done by all forces in kinetic energy. Another lengthy way is to get acceleration, then you do integral f dx and all that, but yeah, it goes lengthy. Clear with this? A decent mains level question. Let's see one more. Any doubts on this? Clear, na, Rudransh? Next one. Q of x, the potential energy, is x power 4 by 2 minus x square by 2. This is your potential energy as function of x coordinate. Mass of the body is 2 kg. The total energy of the system is 2 joules. Find the maximum speed of the particle. Let's get this. Root 2. That's a trap. That's not the answer here. This will be proper mains level questions. The 27, 28. 28 is still a decent one. Any other answer? Try. I'll give you a minute more. ये root 2 से 1 हो गया. Your speed decreased even more. Right, Siddesh, we have one answer. Nee, Shaurya. That's not the answer. We have one answer. One more answer. I'll give you a hint. See, most people think this thing. What is total energy? Kinetic energy plus potential energy. So if you have maximum speed, that means you have maximum kinetic energy. So when kinetic energy is maximum, potential energy is minimum. This I'm sure everyone understands. The mistake everyone does is they think potential energy is 0. Potential energy can be negative also. So that is how you start from there. So see, total energy is kinetic energy plus potential energy. So when kinetic energy is maximum, potential energy is minimum. And that minimum potential energy need not be negative. So u is x power 4 by 4 minus x square by 2. Let's find the minimum value. How to find minimum value of a function? First differential du by dx, x cube minus x equal to 0. We get x is equal to plus or minus 1. Then we check for the double differential, d square u by dx square. That would be 3x square minus 1.
And we also
0
get
also.
0 in the
Yeah,
du by
yeah. So when you keep x is equal to 1 or minus 1, you will get d square u by dx square is greater than 0. This is the condition for minima. So x1 and minus 1 both will give you minima. Therefore, u minimum will occur when x is equal to 1 or minus 1. Choose any one, doesn't matter. So that will be 1 by 4 minus half minus 1 by 4 joules. Your minimum potential energy is not 0, it is minus 1 by 4. Now coming back to this, so total energy is K max plus U minimum, and total energy is 2 joules. Ke max is half, mass is 2 kg. This is V max square. And U minimum is 1 by 4 is equal to 2. So we get V max square is equal to 2 plus 1 by 4, which is 9 by 4, and V max is 1.5 meter per second. The most common mistake now, what people think, total energy is 2 joules. So you get maximum speed when potential energy is 0. They think Ke max is equal to 2 joules. And then you'll get root 2. And that also will be there in the option. So the mistake is that potential energy minimum need not be 0. It can be negative also. Clear with this. Be careful with that because that's a common thing. You think like potential energy minimum is 0. It can be negative. Next one. Let's see one more. This is a force time graph. Let's say this is 5 seconds. This is 10 seconds. And this is 100 newtons. Mass of the body is 2 kg. This F is the force acting on the body. Initial velocity is 10 meters per second. Find work done with the force in 10 seconds. Let's see how will you handle this. Give it a try. Again, be careful. This is not an FX graph. Okay. Maybe right, Samyak. Let's say I think I gave pretty big numbers, I guess. I should have made it 10 newtons instead of 100. Okay. This is not an FX graph. So area under FT graph is not work done. That is another common mistake. People find the work done and think that is that. Be careful. That's how we get trapped. How to do? I'll give a minute more. Right, Anvita. Samyak, Siddesh. I think yeah, all three of you got the same number. So my must be right. Remember, area under FT graph gives you change in momentum. It doesn't give you energy. It doesn't give you work. It gives you change in momentum. I should have given 10 newtons. The numbers became big. Okay. So area under FT graph gives you change in momentum delta P, which is MV final minus MV initial. So how much is the area? Half into 100 into 10. Mass is 2 kg. V final, I don't know. That's what you have to find. V initial is 10. That would be 2 5 500, 250. V final will be 260 meters per second. Shit, that became too big. Then what is work done by all forces? Work done by the force is equal to change in kinetic energy. That would be half into 2 into V final square minus half into 2 into initial speed 10 square. That would be 260 ka square minus 100. How much is that? That'll be whatever, leave it there. That's how you get the answer. Clear? You can simplify it further. So this is 6,700, 500 joules, it seems. I should have given the 10 newtons, but yeah. Clear with this? So be careful what graph is being asked. Is it an FT graph or FX graph? FX graph would have been, your life would have been easy. Area under the graph is work done and you're done. FT graph, you have to be careful. Clear with this? So those are some easy ones, but good ones. Let's see one more. Any doubt so far? Anything you're not clear, please ask. Next one, let's bump it up a more. So we got a spear here connected to a rod. This is a spear of mass m. This here is a light rod. The rod has no mass. Length is L. Again, I'm exaggerating that spear, but it is actually kind of little small one. It's not really too big. Just beside this spear, you have a block. So you have a big block. That's this thing. Maybe I should draw it in blue only. Black is looking bad. The floor is smooth. Now, initially the system is at rest. Then what you did, you just give a slight disturbance. Then what will happen? The spear will start falling down. The picture becomes like this. The spear will start rotating. And in this process of rotating, it will also push the block forward. So the block also will start moving. This mass is small m, that mass is capital M. And we observe when the angle becomes 60 degrees, the block and the spear lose contact. At angle 60 degrees, they lose contact with each other. So they get a small gap. Right? So at this, find the ratio of capital M by small m. So the spear pushes the block forward. Remember, both will be going with some speed. Huh? They are not at rest. They will be moving. They just got separated at that instant. I could ask you that also. Find the speeds when they just get separated. But okay, that M by M will take care of everything. When slightly disturbed, the spear pushes the block forward. And eventually they separate. Because it is fixed on the bottom end, it can't go forever. So it will have to lose contact. And that is happening at 60 degrees. Then what is the ratio of capital M by small m? Let's see how will you handle this. Are the scans on? Anyone didn't get the scenario, please ask. I hope the picture and everything are able to visualize. Try, I'll give 3-4 minutes. Let's start with something simple. Can you find the relation between the speed of the spear and the speed of the block? Start from there. Let's try to find the speeds. When the angle becomes 60 degrees, find the speed of the big block and speed of the spear in terms of m and capital M. Let's find that. How do we start? Let's start with the speed curve part. I keep saying how to find the speed, define your system, then always draw your picture. See, if you don't draw a picture, you won't understand what will happen. So this is how it would look. Which I actually drawed anyways. But let's see how will the speeds be. So just before losing contact, again, they're still touching, but you can imagine a slight gap. Capital M, small m. First define your velocities. So this guy will be going with V2. Remember, this thing is going in a circle. So this will be going with a velocity V1. Is that clear? That spear will be going tangentially with V1 like this because it is going in a circle. Initially, this ball used to be somewhere here. This is your state 1. This is your state 2. This angle is 60 degrees. 90 degrees. So this is length L. So this length will be L cos 60, which is L by 2. That means this sphere has fallen down by a distance of L by 2. Loss in potential energy is equal to gain in kinetic energy. There's only one thing who is losing potential energy, the sphere, but the energy is gained by both of them. So loss in potential energy will be mg L by 2 must be equal to half m v1 square plus half capital M v2 square. There, this is your equation 1. That's your energy equation. Right, Arya. Then what? I don't know V1, I don't know V2. Now what to do? Think, I'll give you a minute. Next thing, tell me one thing. As long as these two are in contact, rigid body constraint, velocity along the normal must be same. So if they're touching each other, just before losing contact, since they're touching each other, velocity and acceleration along the normal must be same. So you get more data from rigid body constraint. Velocity and acceleration along common normal must be same. Just before losing contact. That means when you take the sphere, again, I'm giving a big gap so that I can draw the picture carefully. Remember, this is your normal. So this point here is going with V2, great. This point here is going with V1. This is 90 degrees. This was 60. So this was 30 and this was 60. So velocity component will be V1 cos 60 must be equal to V2. This is the relation between them. So V1 is to V2. The second equation. People get this part also. Second part, the acceleration part, now most people don't realize. So when you look at this sphere, how many accelerations does this thing have? This sphere actually has two accelerations. There is one a centripetal acceleration, there is one a tangential acceleration. And just before losing contact, if you see, this thing has zero acceleration because there's no horizontal force, it lost contact. This acceleration is zero. So after losing contact, the wedge will just keep, the block will keep going with constant velocity. No horizontal force since it lost contact. So when it is about to lose contact, n is becoming zero. That means this sphere also will have a zero acceleration in the horizontal direction. This is 30 degrees and this is 60 degrees. That means a tangential cos 60 must be equal to a centripetal cos 30 must be equal to 0. A centripetal is V square by R, and what about A tangential? So let's do that also. So for this sphere, this is mg 60, 60, and this will be mg sine 60. This is A tangential, and this is A centripetal square is V1 square by L. So A tangential is G sine 60. A centripetal is V1 square by L. And this is the relation here. A tangential cos 60 minus A centripetal cos 30 must be 0. Basically, this must be equal to the acceleration of capital M, which is 0 because you lost contact, so there is nothing there. Yeah, you can substitute here. So this will be G sine 60 cos 60 is equal to V1 square by L cos 30. Cos 30 sine 60 will go off. You end up with V1 square is equal to GL by 2. The Vn is root over GL by 2. There I got a V1. And I know V2 is how much? V2 is V1 is 2V2. That is half root GL. Great. Now we got everything here. So we can substitute in this stuff here. So this thing goes off here. This would be MGL. This would be M V1 square. How much is V1? V1 is root GL by 2 plus capital M. How much is V2? V2 is 1 by 2. So 1 by 4 GL by 2. GL also cancels everywhere. You get M is equal to M by 2 plus M by 8. So we get M by 2 is equal to M by 8. We get M by M is equal to 4. Yeah.
So can we think about it like this way? Can you like correct me in this? I thought that initially the acceleration in the centripetal direction is too much, and
Initially.
yeah, initially, and the velocity is not that much. That's why the rod will apply tension in the outward direction. It will push it to make the g sine theta is too much. So to make the centripetal
Okay.
acceleration like that, the actual one according to the velocity,
ठीक है
the rod
मतलब
will
ऐसा
push.
सोचो, think of like this, centripetal मत बोलो, try to do it in centrifugal force. What you're asking makes more sense. Initially mg sin theta is dominating, centrifugal force is less, so tension is pushing it out. ठीक है,
Yeah.
then
So then when it is just going to lose the, so it is basically taking the help of the normal in the centripetal direction too. And then when it is just about to lose contact, only mg sine theta is enough to give it that centripetal acceleration according to the velocity that it will have at the time.
okay, then what will be about the tension? So you are saying tension the rod becomes 0?
Yeah, the tension becomes 0.
Is that becoming 0? क्या था forces इसमें? In this direction, if you try to take tension T here, mg is also there. Tension 0 नहीं हो रहा है. I'm getting T plus mg cos 60 is equal to mass into centripetal acceleration ना. Okay, नहीं. Let's see, it might become 0. क्या पता. तो V1 कितना था? GL by 2. So this is mg by 2 minus mg. Yeah. सही बोल रहे. It's becoming 0 at that instant.
Okay, sir.
Yeah. At that instant, it is becoming 0. So basically, yeah, I got what you're trying to say. Basically, as long as that thing is there, it would have spiraled out. So after this, the tension will start pulling in.
It is the
You
point
thought
of
like that.
flipping of the tension in the rod.
सही है, but इतना सोच लिया तूने. चलो अच्छा है. But I don't know. Rigid body constant, I found it more comfortable. No, but your method is not wrong. सही था. It will flip. but I'm not sure exam में इतना, if you can think so then great. Not a wrong method, it's right only. All clear with the steps? Any doubts on this? Let's see one more. It's a good one. Definitely try it again. Let's try this. So let's think about this thing. This is, you need to, manipulate a bit. Let's try to imagine a situation. Let's say the block is moving from some x is equal to 0 to x is equal to 8, right? 6 meters. Nee, Anvita. Okay, friction is not uniform, nothing. We have no idea. So the block, right? Initially, the speed is 5 meter per second. It traveled on this rough surface, and when it reached here, the speed became 0. This was the picture. Who is stopping you? Friction is stopping you. So work done by friction must be equal to change in kinetic energy. That would be delta K. Clear? So, which is nothing but if you just take the magnitude, it must be half m5 square. So this is the work done by friction when you go from x is equal to 0 to x is equal to 8. Clear with this? This was the initial scenario. Now he's saying instead of throwing with, right, Arya, instead of throwing with 5, if I throw with 4, then what happens? Now here, instead of throwing with 5, if you throw with 4, Let's try to understand. So half m 4 square can be written as half m 5 square minus half m 3 square, isn't it? So I'll write this as 5 square minus 3 square. So let's try to understand this thing. What is this? This is the kinetic energy at x is equal to 0. What is this? This is the kinetic energy. So this is the 5 meter per second. This is the 3 meter per second. This is the kinetic energy at x is equal to 4 meters. Is that making sense? And what is work done by all forces? Change in kinetic energy. That means this must be work done by friction when you're going from x is equal to 0 to x is equal to 4 meters. Doesn't make sense? That means if you throw with 4 meter per second, right, the block will reach till 4 meters, and by then the change in kinetic energy will be half m4 square, which is equal to the work done by friction. That means the block will stop. Is that making sense? So half m4 square is nothing but work done by friction when you go from 0 to 4. Therefore, block must have traveled 4 meters. Again, try to understand this. When I threw with 5 meter per second, you traveled all the 8 meters. So work done by friction from 0 to 8 is change in kinetic energy, right? Let's flip it now. So can I change in kinetic energy is work done by friction. So I can write half m4 square as 5 square minus 3 square. Where do you have 5 meter per second? You have 5 meter per second when x is equal to 0. Where do you have 3 meter per second? You have 3 meter per second when x is equal to 4 meters. So basically area under this graph is half m4 square, isn't it? So the change in kinetic energy, not exactly area, the change in kinetic energy when you go from x is equal to 0 to 4 is half m4 square. So it must have traveled 4 meters. Kind of making sense. It's little tricky, little weird to get the terms, but that is how you manipulate that thing. You can write, and you can luckily do this only because of that 4. If I had given some other weird number, then it would have been different. Yeah.
Sir, I'm not quite clear like what happened here. I
Hmm.
mean, I was trying by using like integral of mu dx, which we don't know, and trying to
Hmm.
substitute it in the energy equation of 4 meter per second.
Okay.
Uh,
Dekho na, basically, whatever is that mu mg dx, this is nothing but work done by friction, right? Which will turn out to be change in kinetic energy.
yes.
So when you went from 0 to 8, the change in kinetic energy is 5 to 0, the speed became 5 to 0. Right?
Sir,
So
but
I am saying when your speed has gone from 5 to 3, right? If the speed, when you say half m5 square minus half m3 square, chalo, can I write like this thing? Let me write half m4 square as half m5 square minus half m0 square minus half m3 square minus half m0 square.
yes.
So this is the work done by the friction when you go from 0 to 8 meter.
Yeah.
Meaning if you throw with 5 meter per second, you would have gone here. If you throw from 3 to 0, this is the work done to go from x is equal to 4 meter to x is equal to 8 meter.
Yeah. Okay. So, okay, the change in kinetic energy is then minus of that. Okay.
Na,
I got
matlab,
it.
see, if you throw with 5, you have to travel the all distance. If you throw from here 3, you will travel all the distance. That means when you go from 5 to 3, you have to travel this distance in the middle.
Okay. So if we had like, let's say 2 meter per second initially. So
If you
what?
had 2 meter per second
So,
initially,
so we would have
then वो
subtracted
मैनिपुलेट का या
some value like
5
that.
ये 5 तो लेके आना पड़ेगा इंटरप्रिटेशन के लिए.
हाँ.
The 2
Okay.
square को somewhere you need to write it as 5 square minus वो कितना आएगा? So you can
Like 5
calculate
square
that.
minus 5 square
कुछ
minus 2 square.
root 21 square.
1. Root 21.
But problem यहीं पे root 21 you cannot figure out on this thing.
Mm-hmm.
So I need to get an integer there. So
So then also can we like split that mu mg dx का integral like 0 to 8 into 0 to s.
वही हो गया ना रे God. When you say work done, so that only you're doing.
Mm-hmm. So you
That
just
is
have
work
to
done by
compare
friction
the
only.
equations in the end.
Yeah.
Okay.
Clear with this? It's a tough one. It looks easy and all after saying, but still it looks little confusing. So think about this. Still confused? Let me know. That's a bit about it. So next class when we catch up, we'll continue with more. We will see a few more models on this, and then we'll start off with vertical circular motion. I think mostly by next week that we will wrap up this chapter by next Tuesday. So another 2 more classes, mostly we should wrap it up, and then we'll start off with center of mass. So do start solving on this. We did almost 31, so do check it out. And do remember there's a test online until Friday night, so make sure to give it. So yeah, any doubts, anything else, please stay back and ask, or else you're free to leave. I'll see you guys again on Thursday as usual. So same time.